Your IPv6 host is sitting on a network where hundreds of multicast streams could exist. It receives almost none of them, and that is not an accident. Something has to ask out loud first. The asking is done by a small message called an MLD report. It is the host raising its hand and naming one multicast group it wants to receive traffic for right now. That message lands first on the switch, the box between you and everything else. Switches are famously blunt about multicast. By default, they treat it like a broadcast and copy it everywhere. Behind the switch sits the local router, and in MLD it has a title, the querier. It keeps the list of which multicast groups anyone on this link has actually asked for. Beyond the router is the group itself, an address in the FF02 range that stands for a conversation rather than a machine. Traffic sent there is meant for every listener who joined. Next to you is another host on the same link that never asked for this group. Whether it receives copies anyway is the whole difference between a quiet network and a noisy one. And here is the antagonist borrowed from IP4 habits, a filter that blocks ICMP on site. That reflex is harmless enough on IP4 and quietly catastrophic on IP6, as we are about to see. Here is the tension. MLD is not a separate protocol you can switch off. It rides inside IPv6, so the machinery that lets you join a group is the same machinery IPv6 needs to function. Start at boot. The moment your host configures an IPv6 address, it joins multicast groups without being told to, because neighbor discovery, the thing that replaces ARP, is built entirely on multicast. So the host builds a report. In plain words it says, "On this link, I am a listener for this group address. Please keep sending it in my direction from now on." And look at what carries it. The report is not its own protocol on the wire. It is an IPv6 message type sitting beside neighbor solicitation and the errors IPv6 depends on. The report goes out with a link local source address and a hop limit of 1, so it can never leave this link. It is a local conversation by design, and it reaches the switch. The switch passes it along to the router, which is listening for exactly this. The querier writes down that somebody behind this port wants that group and starts a timer against the entry. With a listener recorded, the router can now justify pulling that group down onto the link. Before your report, forwarding this traffic here would have been pure waste, so it simply did not happen. Now the traffic flows. The router forwards the group onto the local link, and the switch is holding it, one hop away from you, with a decision to make about which ports get a copy. If the switch does MLD snooping, it quietly reads your report on the way past and remembers your port. So the copy goes to you and only to you, which is the entire point. Your neighbor never sent a report, so it never gets a copy. Without snooping, the switch would flood every port, and that machine would spend its day discarding a video stream it never wanted. Memberships do not last forever. Periodically, the querier sends a general query to the all nodes address, asking the whole link the same question: is anyone still listening to anything out there? Listeners answer with a fresh report, each waiting a small random delay so the link is not flooded with identical answers. If nobody answers for a group, the router prunes it and the traffic stops. You can also leave on purpose. Instead of going silent and waiting for a timer, the host sends a done message, and the router asks once more before cutting the group off this link. Now break it, block IPv6 at the switch or the host, the way people block ICMP on IP4 and the reports vanish. The router hears nobody, prunes the group, and your multicast simply stops arriving. Two versions exist. The first one simply says which group you want. The second adds source filtering, so you can ask for a group only from named senders or from everyone except named senders. MLD snooping is the switch quietly eavesdropping on messages addressed to routers, not to it. It is technically none of the switch's business, and without that nosiness, a busy link would drown in flooded copies. If this feels familiar, it should. MLD is simply IGMP rebuilt for IPv6. One difference matters here. When several routers share a link, they elect a single querier, the one with the lowest link local address. And this is why IPv6 cannot treat multicast as optional. Every address you configure creates a solicited node group your host must join, so finding your neighbor already depends on the membership machinery working. So the whole cycle. Your host reports the groups it wants, the querier records them and periodically asks again. Snooping switches deliver only to ports that asked, and every message of it travels inside IPv6. That's the whole trick. Next time you are tempted to block ICMP on an IPv6 network, remember that raising your hand for a multicast group happens inside it. Follow how it all runs for more. See you next time.